Good day. We are Group 9 from CE22S10, and we will be presenting the experiment number 2. Experiment number 2, SIEVE analysis. Objective. The activity aimed to introduce the basic principle, significance, and procedures from SIEVE analysis in aggregates, particularly coarse and fine aggregate. Intended learning outcome. The student shall be able to, first, familiarize with basic procedure for the SIEVE analysis of the aggregates. Second, determine the particle size distribution of the coarse and fine aggregates. Third, characterize the aggregate according to the predominant grain size.
Discussion. As conformed in the ASTM 136-98A, the grain size characteristics of soils that are predominantly coarse grained are evaluated by a sieve analysis. A nest of sieves is prepared. So sieves are a colander-like equipment used to strain coarse and fine aggregates to evaluate their standards. So a nest of sieves is prepared by staking test sieves one above the other with the largest opening at the top, followed by the sieves of successfully smaller openings and a catch pan at the bottom. The maximum size of the aggregates depend on the type of structure for which concrete is to be used. Most of the time, the aggregates have a uniform gradation. However, gap-graded aggregates provide better strength characteristics. In gap grading, the sizes of aggregates do not decrease uniformly. Certain size segments are left out in order to obtain better packing and hence a more utilization of cement. Resources that are going to be needed in this experiment are one set of sieves, a weighing scale, scoop or spoon, 2 pans, 1/2 bag of coarse aggregates, and 1/2 bag of fine aggregates.
So for the procedures, uh, the steps for preparation of samples are: first, gather aggregate samples, specifically coarse and fine, weighing at least 1 kilogram, and put it in a pan and then weigh. Second is dry the sample to constant weight at a temperature of 110 positive negative 5 Celsius. Weigh after cooling to room temperature. Next is place sample in a container large enough and to permit spilling when water is added. Fourth is add water and agitate. Fifth is pour wash aggregates over the nested sieves, avoiding decantation of coarse particles. Repeat operation until wash materials are clear. Return all the materials retained in the nested sieves. And last is dry wash sample to constant weight and weigh after cooling at room temperature. For sieve analysis, pass the sample through the nested sieves and weigh materials retained on each sieves. And last is calculate the cumulative percentage passing each sieve on the basis of oven dry weight of the original sample.
Next is data and results. You can see, as we can see in the PowerPoint, the details in 3/8 inches up to pan can be seen in the video, except the cumulative percent passing, cumulative mass passing in grams and remarks. In getting the cumulative mass passing, we use the formula total mass retained times percent passing over 100. The total mass retained is 310.1 grams as we sum up all the given data in the mass retained. Example of getting mass passing is 310.1 grams times 99% over 100 is equals 307 grams. It was already round off in the nearest tens. Next is 310.1 grams times 83.8% over 100 equals 259.9 grams, and so on and so forth. Also, in getting the percent passing, we use the formula 100 minus the cumulative retained. 100 minus 1 equals 99%, and 100 minus 16.2 is equals to 83.8%, and so on and so forth. Moreover, you can see the second to the last column, which is remarks all the data written are passed because of the cumulative percent passing reached or qualified as we base on the specification percent passing. On the next slide please. Mass of sample, mass of oven dry sample, mass of wash oven dry sample, mass retained at 200 sieves, moisture content, fineness modulus, and the computation I said earlier to get the data on the table that we've seen already. Mass of oven dry sample is lower compared to the mass sample, and the mass of wash oven dry sample is higher compared to the two, which is 318 grams. Lastly, the moisture content. On getting this, we use the formula mass of wet sample minus mass dry sample all over mass dry sample multiplied by 100. That's all. Next, reporter.
Hello? Okay. So for the course aggregate data in the reference, their target is to ensure that the sample after sieving is within 99.7 to 100.3 of the original sample weight, which the mass sample is 11.5 grams. For this activity, we calculate the cumulative mass passing, cumulative percent passing, cumulative percent retain of each sieve sizes. We assume that the recorded masses from each individual sieves from 1.5 inch, 1 inch, 3/4, 1/2, 3/8, number 4, and pan. As for the recorded mass retained, the given sieves 1.5 inch is 0, for 1 inch is 0.7 grams, for the 3/4 inch it's 4.6, in 1/2 inch 2.8, and so on and so forth. As what I've said earlier, their target is within 99.7, which is if you total the recorded mass retained after sieving is still 11.5 grams. So for cumulative mass passing, in the 1.5 sieves, the mass retained is 0, therefore the mass passing is 0. However, in the 1 inch sieve, the mass retained is 0.7 grams. So for the formula, calculate the 0.7 grams over the mass sample, which is 11.5 grams times 100. So the mass passing for um, the mass passing for the 1 inch sieve is 6.1 grams. So we do this procedure to the rest of the sieves. For the cumulative percent retained of any sieves, we take the mass passing of that sieve and add it to the mass passing of all the previous sieves. Therefore, if we start to 3/4 inch sieve, the mass passing of it is 40, and add it to the previous mass passing, which is 6.1, we get 46.1, and again, we do this procedure for the rest of the sieves. For cumulative percent, we subtract the cumulative percent retained to 100. For example, the 1.5 sieves, it's 0% cumulative percent retained. Therefore, the percent passing is 100. On 1 inch sieve, the cumulative percent retained is 6.1. Then subtract it to 100. Therefore, the cumulative percent passing is 93.9. However, the specification percent for that sieve is 100, but it only reached 93.93.9. So it failed to reach the specification passing. And again, we do this procedure for the rest of the sieves. However, all the sieve sizes that I did not mention, for example, 3 inches to 2 inches, as we assume the mass retained to be 0 grams. The cumulative mass passing is 11.5 grams, which is the initial mass sample. The cumulative percent passing is 100, and the cumulative percent retained is 0%. Same goes for number 8 to number 200. We assume the mass retained to be 11.5 grams, the cumulative mass passing, and the cumulative percent passing is 0 grams. And 0%, and the cumulative percent retained is 0. Done. Next. The mass sample, which I said earlier, is 11.5 grams. The mass oven dry sample, we assume to be 10.9 grams. The mass washed oven dry sample, we assume to be 12.5 grams. The moisture content, we assume to be 11%. The maximum nominal size is 3 inches. Next.
In this laboratory exercise, sieve analysis of fine and coarse aggregates, we conclude that it is essential to conduct a sieve analysis and to evaluate each ingredient's standards. Samples are oven dried to a constant weight at a temperature of 110 positive negative 5 Celsius, weighed after cooling to room temperature. The sample is placed in a container large enough and to hold even when drowned in water. The mass of particles retained in each sieve is determined. We have we have to sieve an amount of gravel and sand into a successively finer set of sieves in order to know if the aggregates are passed or failed the standard. We thereby conclude that we have successfully evaluated the qualifications of each kind of aggregate that are supposed to use. This is essentially the most important part of construction because this will be the basic ingredients in construction. That's all. Thank you.